Hi all, this is Dr. Shanthi, Professor, RMK College of Engineering and Technology. Now in this presentation, we are going to discuss about the body area network architecture. A body area network consists of computing units, and the main function of them is to aid monitoring and to perform actuation applications in healthcare. And the architecture of BAN can be read or analyzed under 7 subheadings: hardware, network topologies, communication technology, software, deployment, physical environment, and energy resource. As a part of BAN architecture, we have already discussed about that is the basic hardware and then the topology. Now the third subheading what we have to discuss under architecture is communication technology. The communication technologies have been proposed for bands which vary in range, power consumption, frequency of transmission and form factor. The communication infrastructure for bands are very much similarly layered structure to the OSI stack. The band communication protocol stack has 5 layers: the physical layer, the medium access layer, the network layer, the application support sublayer, and the application framework. The physical layer deals with antenna and the radio hardware. Medium access control layer deals with channel access and contention management. Network layer is concerned with routing management and reliable data transfer. Application support sublayer is deals with applications such as securing the communication infrastructure, and application framework provides abstractions of the basic functionalities of the radio to any application. Now the diagram is shown in the next slide. So application framework layer, application support sublayer, networking layer, medium access control layer, and physical layer. Say in the physical layer you have antenna design and radio design, medium access contention management protocols and channel coding. Network layer you have network topology and routing management. Application support layer, security, reliability, time efficiency and energy efficiency. And application framework sublayer is application specific abstractions. Now the available radio technologies that work along with the band are Zigbee, 6-LoWPAN, Bluetooth low power, and IEEE TG6 recommendations. Now a comparison table of radio standards for band is shown here, where the various factors that are used for comparison of frequency, form factor, speed, range, what is the MAC protocol used, and the power. So for Zigbee, the frequency is 2.4 gigahertz, the form factor, the speed 250 kilobits per second, range is 70 meter, carrier sense multiple access with collision avoidance, and this is the power. The same way for 6-LoWPAN, what is it for Bluetooth low power, and IEEE TG6 recommendation. So the various factors are compared for various radio standards. Now coming on to software, the band has two classes of software for programming the sensor and the base station. For sensor, it is event-driven paradigm, whereby computation is scheduled on occurrence of an event. Tiny OS is an event-driven operating system and is most commonly used for sensors. For the base station, there are three popular types of software used for smartphones: Android, which is open source; iOS for iPhone by Apple; and Windows Silverlight. And coming on to deployment, the sensors in the band are either worn on, that is wearable, worn on the body, or implanted within the human body. The exact placements of the sensors on or within the human body depends on the application, right? Say for example, pulse oximeters are worn on the index finger. Now further, recent research endeavors have networked the sensors in the band with car sensors to provide car area network. Now we use band in automotive context also to increase the safety of the driver by providing early feedback on fatigue. Now coming on to the physical environment, the physical environment is the band deployment environment, generally the human body. The operation of the sensor nodes in the band is inherently coupled with the environment through sensing or actuation or through side effects of the computing on the environment. For example, the side effects are generally heat dissipation. Now coming on to the energy source, the sensors and the base station of the band have to be wireless devices in order to facilitate user mobility. Hence, the primary sources for these devices are batteries. The lifetime of the band devices is limited by the battery capacity. For designing sustainable bands, it is very important to use battery in an efficient way. This requires a band designer to understand the load characteristics of the battery as it ages.